Okay, so today's video is going to be about the radian measure. We're going to figure out what a radian is, how do you convert from degrees to radians, from radians to degrees, and then how do you use radians when you're finding sector area and arc length. So to start, we're going to talk about radians. So a radian is a unit of measure for angles. So before we were using degrees to measure the angle, now we are using radians. So here it's shown, this is 1 radian. The measure of theta would be 1 radian, and that's where this radius is equal to the same length of this arc. So that is called 1 radian there. 1 radian is the angle made at the center of the circle by an arc whose length is equal to the radius of the circle. So make sure you have this definition down in your notes. So now we're going to go from converting from degrees to radians. So in the discovery, you saw that the circle with the radian degree, with the radius length of r, that radius went around the circle about 6 times. It ended up being 2 pi times. So all the way around the circle was 2 pi. So in radians, all the way around the circle would be 2 pi. In degrees, all the way around the circle would be 360 degrees. So those two are equal to each other. So 360 degrees is going to equal 2 pi radians. And if you were to divide 360 by 2, you would get 180. So I can take 2 pi and divide by 2 and get pi. And again, to get 90 and pi over 2. And I could take 90 and divide by 2. And I could take pi over 2 and divide by 2 and get pi over 4. And then I'm going to jump back up to 180 and pi. This is going to be kind of my standard to use when I'm converting. So to get from 180 degrees to 60, I have to divide by 3. So I'm going to take pi and go ahead and just divide by 3. To go from 180 degrees to 30, I had to divide by 6. So I'm going to get pi over 6. And then to get 15, it would be pi over 12. So those are some kind of easy conversions to remember, especially 180 degrees equals pi radians. So now we're going to convert 150 degrees. And what we're going to do is use our unit of measurement. So this is 150 degrees. And I'm going to multiply by pi radians over 180 degrees. So these units cancel out the degrees, and then I'm left with radians, which is what I need. So I have 150 pi radians over 180. So now I'm going to reduce, divide by 10, and I'm left with 15 pi over 18 radians, and you can shorten radians to RADS. So I'm going to simplify the 15 over 18. They're both divisible by 3, so it is actually equal to 5 pi over 6 radians. So when you're converting from degrees to radians, you're going to multiply by pi radians, divide by 180 degrees, and that'll get you your conversion. So now we're going to do that again, but this time we are converting from radians to degrees. So I'm going to fill in our information here. This was pi over 3, pi over 4, pi over 6, and pi over 12. So now we're converting 5 pi over 4 radians. So we're going to multiply by 180 degrees and divide by pi radians. So our radians cancel out and we're left with degrees. So you get 5, and then our pi's cancel out as well. So I get 5 times 180 over 4. And this is now in degrees. So before I multiply 5 times 180, I'm going to go ahead and simplify this part right here, 180 divided by 4, because I don't really want to multiply 5 by 180. So if I take 180 and I divide by 4, I end up getting 45. So this is really 45 times 5, which is a little bit easier to do. So you end up getting 225 degrees. Oops. 225 degrees. So when you're converting from radians to degrees, you're going to multiply by 180 degrees and then divide by pi radians, and that's going to get you your answer in degrees. In this case, 225. So in our third example, we are going to use radians finding sector area and arc length, and for this case we're doing arc length. So remember arc length with degrees. The formula for arc length was theta over 360 degrees, that was the fraction of the circle, times 2 pi r. Well, now, since we're using radians, it's going to be theta, but instead of 360 degrees, remember 360 degrees is the total measure of the circle all the way around, but in radians, it's not 360 degrees, it's 2 pi radians. So instead of theta over 360, it's going to be theta over 2 pi times 2 pi radians. So in this example, theta is equal to pi over 2, and our radius is equal to 14. So we're going to plug those in. So theta is pi over 2 divided by 2 pi times 2 pi times 14. Now, in this case, I'm going to go ahead and cancel my 2 pi's, 2 pi and 2 pi. You can see that those would cancel out, and I'm left with pi over 2 times 14, or 14 pi over 2, which simplifies to 7 pi. So the arc length in this case would be 7 pi radians. Okay, for our fourth example, we're going to do sector area. So remember, for sector area in degrees, it would be theta over 360 times pi r squared. Theta would be your angle in degrees, 360 is the total, but for radians, it's going to be theta over 2 pi times pi r squared. So that's what we're going to plug it into. In this case, theta is 3 pi over 2. Pi over 2, and our radius is 4. So we're going to plug that in. So theta is 3 pi over 2 over 2 pi times pi, and then our radius squared. So you can see where I've plugged everything in. I plugged in theta here, and I've plugged in my radius here. So remember, when you are dividing fractions, this is like 2 pi over 1. So you keep the top one, 3 pi over 2, times changing the operation from division to multiplication, and then flipping the bottom one. So 1 over 2 pi. And this is going to be times 4 squared is 16. So this is going to be 16 pi. So now I'm going to simplify that by multiplying straight across. Before I multiply, I can see that this pi and this pi will cancel each other out. And so I'm left with 3 times 16 pi on the top, and 2 times 2 is 4 on the bottom. So before I multiply 3 times 16, I'm going to go ahead and simplify this 16 and 4. 16 divided by 4 is 4. So that's going to leave me with 3 times 4 pi, which is 12 pi. So the sector area in this case is going to be 12 pi radians. All right, our last question, example number 5, it says, in a circle with center O and the central angle AOB, and I'm going to stop right there. I'm going to go ahead and draw a picture, because if I don't have a picture, it's kind of hard for me to tell. So this is O, this is A, and this is B. And it says the central angle measure is 5 pi over 4. So it's saying that this measure right here is 5 pi over 4. That's how much of the circle I have. The area of the sector formed by the central angle AOB is what fraction of the area of the total circle? So it's talking about area of a sector and area of the total circle, but it's really just asking me what fraction of the circle it is. So it's saying how much is this from the whole thing? Well, I know that I have 5 pi over 4, and I know that the total circle would be 2 pi, not the total area, because remember this is an angle, but I know the total measure around the circle would be 2 pi. So what I'm going to do is, this would be my angle, and this is the total. I'm going to write my fraction. So I have 5 pi over 4 out of 2 pi. So again, we're dividing that fraction. So we're going to keep the top one, 5 pi over 4. We're going to change the operation to multiplication and then flip the bottom 1 over 2 pi. I know that my pi's will cancel out, and I get 5 over 8. So the fraction of the circle is 5/8.